Now coming to the chemical properties. See, all metals can combine with oxygen, and what do they form? Metal oxide. So all metals, metal plus oxygen gives us metal oxide. Let us take the case of sodium. Sodium plus oxygen gives us sodium oxide. Potassium plus oxygen gives us potassium oxide. Calcium, calcium oxide. So calcium combined with oxygen to form calcium oxide. Magnesium also combines with oxygen to form magnesium oxide. Same is the case with aluminium and zinc. Aluminium plus oxygen So what we find is that gold, platinum and silver, no action, and that is why they are called noble metals, and that is why their jewelry is preferred, silver and gold, because they don't get spoiled easily, especially gold, and it is rare also. So that is why the gold price is forever soaring. Now what happens to these oxides? What is their chemical nature? If we take any oxide, like say calcium oxide, dissolve in water, we get calcium hydroxide. We can test it with the help of litmus paper. Blue litmus paper, no action. Red turns blue. So that means metal oxide plus water forms metal hydroxide. Same is the case with MgO plus H2O, MgOH twice, Al2O3 plus water, so this is how the hydroxides are formed. What does that mean? That means all metal oxides are basic in nature. Coming back to burning, whenever it combines with oxygen, actually it is burning, combustion. Now sodium and potassium are the alkali metals, they are very reactive. Just like some people get angry very easily, you say a thing and they will get annoyed. Or some are very sensitive, you tease your friend a little, she or he starts crying or starts sulking. So they are like your alkali metals, very reactive. While there are other who do not get annoyed so easily. So they are like, say, you can say noble metals. So sodium, because it is so reactive, it immediately combines with oxygen, and this reaction is very exothermic. Exothermic means lot of heat is produced, and as a result it catches fire. What we find here is that sodium and potassium burn instantly. Then coming to calcium and magnesium, we find that they also burn brightly, but the reaction is comparatively less. In the case of iron, if we burn iron, what we find? Its color changes. There is no flame, but it becomes red hot. But if we sprinkle iron filings on the flame, there will be burning, there will be flames. Metals also react with water. Once again, the alkali metals sodium and potassium are most reactive. Even with cold water they will react. In fact, when sodium and potassium is exposed to air, moist air, it immediately reacts with water and there is a fire. Why so? Because metal plus water give us metal hydroxide and hydrogen. It is the hydrogen that catches fire because it is combustible. In fact, when we prepare hydrogen, one way of testing it is that if we bring a burning splinter near it, it will start burning with a blue flame or there will be a sound of pop. So, hydrogen can burn. So, we have to be very careful when sodium and potassium are exposed to moist air. So, that is why sodium and potassium stored in kerosene oil to prevent the reaction you can say. Fire. So, Na plus H2O will form NaOH plus H2. Calcium and magnesium can also combine with water, but the reaction is less vigorous. Calcium can combine with water, cold water, but magnesium needs hot water, but the reaction will be similar. Calcium plus water hot water. Now, when I showed this reaction to you, what did we see? That magnesium started floating on water. Why? Because hydrogen bubbles get accumulated on the surface of the metal. So, metal becomes light and there is a buoyancy and it can float in water. So, both calcium and magnesium they start floating. Now, let us see what happens in the case of iron and aluminum. In the case of aluminum, we get aluminum oxide and hydrogen. And in the case of iron, we get Fe3O4 plus H2. Now, going back to oxides, we saw that oxides are basic in nature. Because they are basic in nature, when we were doing acid, base and salt, we saw that acidic oxides can also combine with bases to form salt and water. Aluminum oxide is unique that it can combine both with acid as well as with base. Let us take first the case of hydrochloric acid. So, when Al2O3 combines with hydrochloric acid, what we get is AlCl3 plus H2O. Right? But it can also combine with a base like sodium hydroxide. This is called sodium aluminate. Now, such kind of elements which combine both with acids and bases as their oxides are called amphoteric. So, you can say aluminum is an amphoteric element. What happened just now when we poured dilute hydrochloric acid over zinc, iron and aluminum? Immediately lot of gas was being produced. There were bubbles, but of course not at the same speed. Why we didn't take sodium or potassium? Because they are very reactive. They would have immediately started producing hydrogen and that could have caught fire. Even in the lab preparation of hydrogen, we use zinc because zinc is moderately reactive. We do not take sodium or potassium or we do not take copper, because what happens in the case of copper is that the reaction is very slow. We want enough of hydrogen, but we do not want excessive reaction. So, we will now study what happens in the case of acids. When acids combine with metal, what we get is salt plus hydrogen. Like say HCl dilute plus zinc granules, zinc chloride and hydrogen. In the case of aluminum, aluminum chloride plus hydrogen. Iron and aluminum also form their respective chlorides and hydrogen is produced. Same is the case with sulfuric acid. H2SO4 plus zinc gives us zinc sulfate. But same is not true for nitric acid. You know, nitric acid is a very strong oxidizing agent. So, whatever hydrogen is released, it is immediately oxidized to water, and nitric acid releases one of its oxides, either NO2 or NO. So, in the case of nitric acid, the case is different. So, here the case becomes different, although nitric acid can react with some other metals like manganese. So, acids have this unique property that the hydrogen gets displaced. This is an example of displacement reaction. Why? Because just like metals, hydrogen is also positively charged ion, and this positively charged ion is less reactive than some metals like sodium, potassium, calcium, magnesium, aluminum, zinc, iron, lead, but it is more reactive than some others like mercury, gold and silver. So, the metals which are more reactive, they can replace hydrogen from their acids, but the metals which are less reactive like gold and silver, they cannot. So, in a way that is good. So, your gold and silver jewelry is safe from acids.